Hello everyone, welcome back to the channel, and today let's amplify our knowledge with BGP. So by the end of this topic, you should be able to understand what BGP is, and you should also be in a position to configure BGP. So to understand BGP, first of all, you need to understand what is called autonomous system. So an autonomous system is a group of IP network, for example, an internet service provider that uses the same routing policy. So IBGP is divided into two, so the interior border gateway protocol and the exterior border gateway protocol. When you look at our topology here, AS65009, the SwitchB, SwitchC, and SwitchD, they are on the same autonomous system. So those are going to establish what is called IBGP peers. Then SwitchB and SwitchA, they are going to establish exterior border gateway peers because they are on different autonomous systems. So also you should understand what is called the BGP messages, how they are going to establish BGP sessions. In order to establish a BGP session, you are required to configure the router ID. Without router ID, the BGP won't be able to establish the peer, the session. So also there are finite state for the BGP. So I'm going to look at them. The finite state for the BGP, we have got the idle state, connect, active, and open start, open, confirm, then establish. But the common BGP, the common BGP states here are idle, active, and establish. Those are the common BGP states. Established. So those are the BGP states. Then there are BGP messages, the messages that are being exchanged while we are establishing a connection. So first of all is open message, and open message here as open message is sent as open message is sent to establish a BGP peer relationship. So sent to establish peer relationship. With the speakers. So with the BGP speaker. So a BGP speaker is a device that sends the BGP packets. So that is the BGP peer. Then the next is BGP. The next BGP message is the BGP update message. So update message here. I've got the update message, and also I've got the notification message. Notification message is used to terminate BGP connection. Terminate BGP connection. Then the keep alive message. Here. The role of the keep alive is to maintain a BGP connection. Maintain a BGP connection. Then our last is route refresh, and route refresh request for the peer to retransmit the routes. So request peers to retransmit the routes. So Route refresh is just request the peers to retransmit the route. Then update. This one is just actually send the BGP routes. Send the BGP routes. To peers. So update send the BGP routes to peers after it has established a peer relationship. So those are the BGP messages, and these one are the BGP states. So it's important to understand BGP states and also the messages that are being used to establish the neighbor. They are used to establish the neighbor session. So that's the introduction. Now here we are going now to configure just the interfaces and give them IP addresses, and also allow the respective VLANs to pass. And after that, we are going to configure the BGP to enable the routes reachable. So let's start with our switch 1 here. Switch 1 here, we're going to forward how many VLAN 50 and VLAN 10. So UTM. So switch name, this is switch 1, switch A, and switch A we are going to create a VLANs. So VLAN batch 10 and 50. So VLAN batch 10 and 50, and also after that we create what is called we create interface VLAN if 10, we give it IP address of IP address here will be 192.168.1.2/24. Then VLAN if 50, IP address of 10.1.1, 10.1.1/16. You quit. And also we are going now to tell it to allow the respective VLAN. So interface gig 0/0/1, tell it port link type trunk, port link type trunk, port link type trunk, tell it port trunk, allow pass VLAN 10, then enter gig 2, then port link type here is trunk, tell it port trunk to allow pass VLAN 50. Save and go to the next switch. In our switch B here, so UTM and give it the reverse name of switch. This is switch B. Then the VLANs here, we have got how many VLANs? We have got 3 VLANs, VLAN 10, 20 and 30. So create VLAN batch 10, 20, 30. So interface VLAN if 10, IP address of 192.168.1.1/24, and for VLAN if 20, give it IP address of 172.16.3.1, So IP address of 172.16.3.1/24 for VLAN if 30, give it IP address of 172.16.1.1/24. You quit and enter the interfaces and allow the respective VLANs to first interface gig 0/0/1, port link type, trunk, port trunk, port trunk. Tell it to allow pass a VLAN 10. Then you enter gig 2. Gig 2, tell port link type here is trunk, and trunk you tell it to allow pass VLAN 20. Then enter gig 3, tell it to allow VLAN 30, port link type trunk, allow pass VLAN is 30, VLAN 30 to pass. So you save, go to the next switch here, that is switch D here, UTM. So give it switch D. So this is switch D. On switch D, what we do, you enter you create the VLAN. So here is going to be VLAN 30 and 40. So VLAN batch 30, 40, VLAN batch 30, 40, and now you enter interface VLAN if 30, IP address of 172.16.1.2/24. VLAN if 40, give it IP address of 172.6.2. So IP address of 172.16.2.2/24. Quit and you create the VLAN interface. So interface gig 0/0/ /3 gig 3. So port link type here, this is a trunk, then port trunk, tell it to allow pass a VLAN 30, and enter gig 2. Port link type here is trunk, this is a trunk port, and I tell it to allow pass VLAN 40. Allow pass VLAN 40. Lastly, we configure switch C. UTM. This is switch C. So switch C, we are going to create a VLAN 20 and 40. So VLAN batch 20, 40. VLAN batch 2040, and we create the interface VLAN if 20, IP address of 172.16.3.2/24. Then for VLAN 40, VLAN 40, you give it IP address of 172.16.2.1/24. Quit. Enter the gigabit interface. So interface gig 0/0/1. Port link type. As the trunk. Port trunk. Allow pass VLAN 20. So then you enter gig 2. Port link type here is a trunk. Then you tell it trunk to allow pass VLAN 40. Allow pass VLAN 40. Control save. Say yes. After we've configured the layer 3 interfaces, now the next thing we are going to do is now to configure layer 3, the routes. So we are going to configure the BGP to enable routes to be reachable. So we start by creating the IBGP peers. So here we have got, this is autonomous 65009. So we start with switch B. Here is switch B. Let's start with switch C. So BGP here is 65009. Then the thing we are going to do is we are going to create the router ID first. We said the router ID in a BGP is what is going to establish a BGP sessions. So we must configure BGP routes. So here we are going to use the loopback. So that is let's say this guy here, we are going to give it 172.17.1.1/32/24. So that is going to be the router ID for that guy. Then the router ID for this one will be 172.17.2.2. The next will be 172.17.3.3. Let's put it .4.4. Then the upper guy here will be 172.17.3.3. So those are the ones that are going to be used as the router ID. So now the router ID here will be 172.17.3.3. Then it's going to establish a peer with this network of 172.16.2.2. So peer here will be 172.16.2.2. The S number here will be 65009. Then the next is also going to establish a peer with, so it's going to establish peer with 172.16.3.1. So here a S number here, S number will be 65009. So after that, you also come on switch D here and you create the BGP. So you quit. So BGP here will be 65009. Then the router ID here will be 172.16.4.4. Then peer here is going to establish peer with 172.168.1.2.1. AS number here will be 65009, and the next peer is going to establish with the 172.3.16.1.1.16.1.1. So AS number, autonomous system number here will be for 65009. So for the IBGP, so display this. Okay, after that we are going to create also IBGP peer. So under that, so BGP peer here, BGP here is 65009. Router ID here will be 172.17.2.2, and here we are going to tell it. We're going to tell it to peer to establish a speakers BGP peer with 172.16.1.2. AS number here will be 65009. The next peer is going to establish with peer 172.16.3.2. AS number here will be 65009. After that, good. The next, after creating the IBGP peers, let's display IP routing table. IP routing table here will be. So we see the routes have been learned directly. Then we are going to establish a exterior gateway protocol between SwitchA and SwitchB here. So enter BGP 65009, and here we are going to establish BGP peer. So the peer here will be 192.168.1.2. Then autonomous system here will be, autonomous system number here is 65008. That is for the exterior. After that, we are going to tell it after that IPv unicast. So the next is you come to this the switch here. We also enter, so BGP here will be BGP on this side will be BGP 65008. Now in that network we are going to attach its interface. So the peer here will be, we're going to establish peer with 192.168.1.1, and AS number S number will be 65009. So for the autonomous system, the next autonomous system. So after that, you are going to advertise. We're going to advertise this network of 10.1.1.1. So these are /16, not 15. We're going to advertise that network into this other autonomous system. So you say network so IP family IPv4 family unicast and unicast. Then we advertise that network of 10.1.1.1 advertised to that network. Then when you come to, we are going back to this our switch B here that is going to establish neighbor relationship with switch A. We tell it to import the direct routes. So on that BGP, now IPv4 family unicast, tell it to import direct routes, import route direct, then you quit. Okay, yes, so let's display IP routing table protocol BGP and display IP routing table protocol BGP. Here you can see here the destination network of 10.1.1.0/16 is learned through exterior gateway protocol, and the next hop is 192.168.1.2. Display BGP routing table and display the BGP routing table here. It's only one next hop that is known here, so meaning that the IBGP peer here has not been established. So BGP so these are our routers here on this sides here have not learned the IBGP peer, so it doesn't know about that network, so they must learn IBGP peer first. So let's see here, display. I'm going to display IBGP IP routing table. See the routes that have been learned. So IP routing table. See here, you can see the direct routes that have been learned. But when you come to this guy here and see display IP routing table, it has learned one route through BGP. So the reason route of 10.1, the reason why that thing was not able to learn the routes from IBGP is because you see here switch B, switch C and switch D, they are creating a loop here, so the packets are being forwarded here endlessly. So to solve that problem, to enable layer 3 now, what we do to enable layer 3 and so that the VLAN interfaces can exchange the packets, what we do, you come on the interfaces that connect to the other devices, the app devices, and so enter interface gig 0/0/1 /0/0/2. Then you disable STP on that interface. STP disable. Then the next thing again will be, now you enter gig 3, and again you also disable STP or quit. So after that, let's display BGP routing table. BGP routing table, and see. When you display BGP routing table, you can see the routes that have been learned. So we have got 10.1.0.0/16 and 172.16.1.0/24. Another route is 172.16.3.0/24. Then the last one is 172.168.1.0/24. So then the next hop here, you can see the next hop for those routes. The next hop for those routes are being shown there. The local preferences here is 100. Then the AS number for the exterior will be 65008. Then also let's display IP routing table, protocol BGP. You can see the destination here will be that one, and it has been learned through IBGP. And the next stop is 10.168.1.2. that is, you can see here the next stop is this one here. Then another network we've learned is also 172.168.3. it's a gateway, it's an IBGP. The next stop is 172.16.1.1, and they were both learned through VLAN interface, VLAN if 30. So that's how you can check. Now display BGP peer, and display the BGP peer. You can see the peer we have got 172.16.1.1, another peer of 172.16.2.1. and you come to switch B here. I display BGP peer. You can see the peer here we have got 172.16.1.2, 172.16.3.2, and another peer of 192.168.1.2. and the state here, you can see the state here is established. A state is established. As we say, the common states here are established, idle, and active. So the state is established. The peer here establish a peer relationship. Now let's see, can we now reach this network of 10.1.1.1 while we are on switch D or switch C here? So on switch D, let's try and ping that network. So ping 10.1.1.1. The packets are able to go through. Also on switch C here, let's ping 10.1.1.1. the packets are being able to go successfully. Let me try on something here. Also, while on switch 1 here, let's see if you can ping an interface on switch C. So ping 172.168.1.2. 8.3.2, and it's able to reach SwitchC. So that's all about BGP, guys. So that was just the basic configuration for the BGP, but there are advanced level for configuring BGP. So we will look at the advancement as we proceed. So I hope you guys have enjoyed the session, and remember to subscribe to our channel so that you can support our video production. So thank you.